Okay, so in this module, we're going to continue off of everything we saw previously with variables and doing some evaluation of values. And this time look at something a little bit more useful in terms of data, and that's strings. And so strings are going to be used to represent anything that we output to the user and often what the user actually types in as well. So what is a string? A string is just a simple sequence of characters. They can contain just the normal alphabetical characters A through Z, upper and lower case. Incidentally, everything in programming is typically case sensitive. So upper and lower case, the difference between an uppercase A and a lowercase a usually is a huge difference. There's very few cases where the case does not make a difference. So you should be aware of that when you're naming variables, like we talked about before. Variable names are of course case sensitive. We'll see how we can compare strings, and we can evaluate whether they're the same later on in this lecture. And again, you want to remember that if things are different case, uppercase versus lowercase, they are not the same. Character data or strings also include any of the special symbols that are available on your keyboard. Actually, the character set that the computer uses is actually quite a bit bigger than what's on your keyboard. But you can, kind of a good rule of thumb as you're starting off is that it's anything that you can type. One of the things that confuses people, that maybe the first time they started programming and they start to think about different data types, is that the keys that correspond to 1, 2, 3, all the way out to 0 are also characters. So when a user types a specific character, um, that's not an actual integer. String literals can be surrounded with single or double quotes. So when you're actually writing them in your program, this is the way they're going to look. So again, you have your pick whether to use a single quote surrounding it or a double quote, but you can't mix it. So you can't start ABC with a double quote and end it with a single quote. They have to match up. Generally, there's no real rule of thumb as to which one that you should use, but what I'd say is try to be consistent. Pick one that you like and try to use that as often as you can. We'll see some advanced usage of this. There's a reason why we can use either one. It helps us embed these characters within strings. We'll get there later on. For now, you can use whichever you want. Again, remember that just because there's numbers inside of a string, that does not mean they represent actual numeric values. So, if I enclose the number 1 in quotes, or the number 1, 2, 3, 4 in double quotes, that does not mean that it's 1,234. The computer can't do arithmetic with it. It is simply a string that happens to have symbols that look like numbers in it. If you're coming from a language like C++, Java, most standard typed languages, one thing that I do want to point out here is that kind of oddly there is no specific data type corresponding to a one individual character. So in C++ we have the char variable, same thing in Java. You might wonder why you don't have that in Python. Um, it turns out that you really don't need it. Python's a little bit higher level language. Typically in C++, when we deal with individual character data, we're kind of starting to think about bytes and bits. In Python, we don't really typically do that, so there's no difference between a string of a single character and a string of multiple characters. It's all strings. If you're not familiar with C++, you can sort of ignore that. We can do a lot of different things with strings. So we saw standard arithmetic, multiplication with integers and floating point values. Strings work as well with several of the operators and in some pretty nice ways. So like we saw before, of course, when we write 2 plus 2, that's going to be 4. Those are just standard numbers, and notice there's no quotes around these. Right? So when we type a number that does not have quotes around them, those are going to be standard arithmetic values. They're going to be integers or floats. If I write the string 2 plus the string 2, that actually is going to do a concatenation. So it's not actually going to do any math, but it's going to add the two strings together by putting them right next to each other. So I'll get 22, or really 22. Again, there's no mathematical operation there. It's just adding the two strings together. ABC plus XYZ is also just going to give us the full string ABC XYZ. So the plus operator works. The minus operator does not. There's no real basis for string subtraction, but the plus operator sort of makes some intuitive sense that we can kind of attach strings together. Pretty nicely, we can also do multiplication with an integer and a string, and that'll give us the result of that expression will be whatever the string is, concatenated 3 times, right? So 3 times A will just be A. A times 3 will be the same thing. So that's a pretty nice way to be able to build some strings. Occasionally we'll have to do that, especially with some user input. String comparisons. We can tell whether or not a specific string is equal to another, and typically this is because we have strings in variables, not necessarily, I mean, this is not really an interesting test here, but if we had a variable maybe containing this string, we'll talk about that in a second, we could do these comparisons. So the double equal sign corresponds to the comparison to see whether two things are equal. That's not an assignment statement. A very, very common mistake in programming is writing one equal sign. Make sure that you don't do that. That's going to, in this case, be an error because we can't assign anything. The left-hand side is not a variable. But in other situations where you do have variables here, it can cause a lot of tricky and hard to find bugs. The not equal exclamation mark will return true if they're not equal, and as I said before in the beginning of this lecture, everything is case sensitive, so the lowercase version ABC is certainly not the same as the uppercase version ABC, so that'll return true in this case. We can also do comparisons. The way the comparison operators work generally is just alphabetical. So, you know, A is less than B because A comes before B in the alphabet. That's all pretty standard stuff. The result of comparing uppercase and lowercase values, or you might want to say is the hashtag symbol less than the @ symbol. Those are a little bit less intuitive. In this case, lowercase z is less than, uppercase z is less than lowercase z, and that's because the uppercase letters are considered to be smaller than the lowercase. And why are they considered this way? Well, I mentioned in the first set of videos that everything really in a computer is represented by numbers. And here I'm showing you the ASCII table. You certainly don't have to try to memorize this or anything like that, but and for our purposes, the first column here and the last column here are what we're probably more concerned with. We've got a decimal value of 32 corresponding to a space. Right? And so these are all non-printable characters over here, or just standard letter characters. And every single number from 0 all the way down to 127 is assigned to be a specific character. Okay, so we can see space, all the symbols here. So indeed, $sign would be less than the %sign. That's relatively arbitrary. We can also see as we go down here, we can see that the uppercase values come before the lowercase values. So an uppercase A is actually value 65, while a lowercase a is value number 97. And that's actually why those string operators work that way. Again, we don't have to memorize this, but you should be aware of it. You should understand that every single character that is supported by the system ultimately corresponds to an integer value, and so they can be compared. Okay, so things that don't work. So we saw that concatenating strings can be done with the plus operator. I can take a string and multiply it by an integer, which will cause the string to be repeated that number of times. But doing like an integer plus a string doesn't make any sense, and it's hard to think about what that would really do. And in Python, most of the things that don't really make sense will give you an error. and that's probably a very good thing. So if you do 3 plus the string 3, you'll get an unsupported operand type. Int and strings can't be added together. Likewise, multiplying a string by another string, I don't know what that would really mean if you wrote that. You'll get a type error in Python. It'll tell you can't multiply a sequence of non-integers. And also comparisons. So trying to compare a string with an integer, or a string with a floating point value, again, doesn't make a whole lot of sense. I specifically mentioned Python 3 here because Python 2, and remember the textbook does use Python 2. Python 2 does try to take some liberties in figuring out what you might mean by this. It tries to do some casting, converting those strings to integers and things like that. Generally, that's not a great thing, and in Python 3 that was taken away. And so in Python 3 you will get an error here, and we'll see how we can do this conversion. So if we have a string and we think it is an int, maybe the user types it in, maybe we've read it from a file, we'll see that in a few lectures from now. We can try to convert it into a full-fledged integer. And the way to do that is to write int and then put the string inside these parentheses here. So this, it's called a function actually. This function will take this string and it'll attempt to convert it into an integer. And it'll succeed in this case. 3 is an integer and 3 is less than 4, so we'll get true. We can also take strings and turn them in, or we can take integers and turn them into strings. So you can take the value number 95 and convert that to a string, which essentially just, if we were to imagine what the computer's doing here, it's really just creating an actual string there. So if I take the value 95 and the value 123, of course 123 is greater than 95, but when we turn them into strings, again I'll keep it like this, when we turn this into strings, 9 comes after 1 in the ASCII table. And string comparison is just done by the first character, and then the second character if there is a tie, and then the third character, and so on. So this actually will return true because it's an actual string comparison because of that string function. Generally, anything can be turned into a string. Whatever you have, whatever variable or whatever value you have, you can turn it into a string representation. In fact, you can. It's not really useful, but you can do string A, and that'll just return the same thing. Certainly, some things won't be able to be turned into integers, though. The string and the int notations are really just functions, as I said. We'll learn a lot more about functions in some future videos, but at this point we can think of whatever's in those parentheses as being a parameter. And so when we call int with some string, that string parameter, we'll evaluate that, we'll look at that and see whether or not that can be turned into an integer. And if it does, the int value will be returned. It'll be replaced. You can think of it, that notation here, as being replaced with the actual return value or the integer that gets produced from that. There's lots of different functions in Python that are available to us. We'll see most of them throughout this course. The length function, or len, will take as a parameter any sequence. All right, so a string ABC, the length of it will be 3 because it's 3 characters, and we'll see that the length function cannot only just take strings, but we'll see that it take lists, tuples, dictionaries, all that kind of stuff as we proceed. But right now we can get the string's length just by calling that function. Okay, so just like regular numerics, strings can be assigned to variables. So here we've got the variable named A being assigned to the string literal ABC, and we can call print and print out the variable. Of course, the variable points to that string, so we'll get ABC out to the console. And by the way, we're seeing print, and if you can kind of remember what we had on a previous slide, we had int A, we had length A. It's the same syntax, right? Print's another function. right? And print actually will allow us to print out a sequence of things. We can do print A, comma, B, comma, C, and it'll print out the concatenation of whatever's in A, B, and C. Okay, so just working with variables, I can give you a little bit of an example here. So I happen to record this video during a few times that the Mets have been playing well, so I was thinking about them. And so we've got a variable team equals Mets, and then we can do some substitution. So again, we're seeing this print function being used, and now being used with several different strings. All right, so we've got let's go, comma, team, comma, exclamation mark. All right, and so this is a use of a variable embedded sort of in an output containing some constants, right? Some literal values. So let's go and exclamation mark, no matter what this value for team will be, is always going to be there. And when we print it out, it'll show up as the concatenation of let's go, and then whatever value is inside of team. Right? The commas don't print out to the screen. They're replaced with blank spaces. Right? So we see let's go, space, Mets, space, exclamation mark. And later on in the semester, we'll see how to get rid of that space. It's pretty easy to do. I want to point this out though, because if you're using Python 2, this print statement still works, but it works very differently. And that's because the print statement itself was dramatically changed between Python 2 and 3. So if you type Python, or if you've installed the wrong version of Python instead of Python 3, you might end up running this program, and this program's linked from my webpage, and you can type it yourself, of course. You might see something print out like this with actual parentheses still there. If you get that you're running the wrong version of Python, just make sure that you're using Python 3. If you've only installed Python 3, if you're on a Windows machine, you probably don't have to type Python 3, but you want to make sure you get that straight. There'll be lots and lots of sort of small things that are different between Python 2 and Python 3. When we have a string, we can also access each individual character. Right? And so this is called indexing. And in Python, we've got a really flexible indexing system. And so one of the first things that we want to recognize is that an index represents a position within a sequence, and a string is just a sequence. So I'll just call them strings here. But everything that we're going to learn right now will also pertain to list of integers, list of anything, all right, any kind of sequence. So we've got a string hello world, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters in it. And again, that space, that is a actual character. It's got 11 positions in it. The first position, its index is always 0. Right? So this is a really important thing in programming, in every single aspect of programming, no matter what language you're using. 0 is the first number, not 1. So don't make the mistake of don't forget that. Don't make that mistake. The first element is always indexed by 0. So if I call print with a bracket 0, those bracket notations represent the indexing notation. That's going to print out whatever value is at position 0. So it'll print out DH at this point. If I call print A5, we've got 0, 1, 1, 2, 3, 4, 5. Right? And it's going to print out a blank string. Right? That'll just print out nothing to the screen because that's what's at position 5. You want to make sure that you get real good at indexing. There are indexes that are invalid, right? So if I tried to do a bracket 13, there is no 13th position here, and we'd get an error. Right? Indexing into a string and indexing into a list is going to be one of those very, very fundamental things that we do in programming. Almost all languages use this notation. Python's somewhat unique in that it also allows you to index from the end. So if you're coming from a different language, this might come as a little bit of a surprise to you, but saying A-1 actually works, and works quite well, and will print out the last value. Right? So when we use an index with a negative value, the index is actually going from the end. And it's actually sort of intuitive that it doesn't start at 0, right? Because there's no -0, right? But sometimes people get mixed up with that. The first element, if we're going backwards, is going to be indexed at -1. All right, so index at -3 would print out the character R. Indexing notation can be expanded. And again, this is something that's relatively unique to Python. It can be expanded to represent a range or a slice of the string itself. So if we use the indexing operator, these brackets, but we give two values separated with a colon, we're indicating a range, or in this case, a substring of the actual value that we have. So I've got this variable A, it has hello world in it, and we can really plainly see that space now. This is really how it would be structured in memory. These under the hood here, we really do have 11 specific variables. And if we use this notation, A3:8, we see what we get. So first of all, the start, the left-hand side of this colon, that's going to be where we start inside this string, and that's inclusive. So the start index is inclusive. When I say start 3, I will include the third position. It's really the fourth value because we have 0 starting at the first value. The right-hand side, the colon 8, is an exclusive. All right, so it is not an inclusive index. So we will stop right before 8. So the actual result here will be LO space WO. If we do A0:5, again, it's inclusive. So we'll start with the 0. We'll have the H, and it'll go all the way up to, but not including the fifth index, 5. So we'll get hello. There's some shortcuts here. So we don't necessarily have to write the 0 here. If we leave that out, it defaults to 0. So :5. Now again, if I just typed in A5, that would just give me that particular character. But by doing :5, Python knows that I mean 0:5, and it'll give me that full string. So the first one, if it's omitted, will be defaulted to 0. Likewise, if we omit the last one, and this is actually usually a lot more useful because we might not, if we have a variable, we might not really know or want to actually count what is the last index. So, typically we would write this as 6:11, right? Because there would be up to, but not including the 11th position. But if we don't want to really think about that very hard, and we might make a mistake, it's certainly much more convenient to just say start at 6 and give me everything else. All right, so if we leave it out, if we leave the value on the right-hand side of this colon out, that's perfectly acceptable. By the way, we can also use variables here. So if we did something like this, we can include in these colons a variable, not just an actual literal number. Right, so this would just give us starting from 6 and up to, but not including 8, and it'll just give us WO. Right, so this indexing scheme is very flexible, and it can contain expressions, it can contain variables in addition to literals. Okay, so that's all we have for strings right now. We'll be using strings throughout the entire lecture. Probably the biggest takeaway here for strings is how to write them, making sure that you use the single or the double quotes and not mixing them. And then the other thing that you really want to practice and make sure you get a hold of is the indexing scheme. So indexing starting at 0, and making sure that you recognize how to define slices of strings, to get substrings, to get specific characters out of that string. That's going to be continuing. That's going to continue to be with us. You're going to see lots and lots of programming examples, and on homeworks, you'll have to do this quite a bit.